it will collide here. A rough diagram I'm showing. After impact, it will rebound. So let the initial velocity of approach, let it be u. It will rebound with a speed v. Let the angle of incidence theta, let it be. So shall I call this a line of impact or normal? Anything? Line of impact or common normal? And what about this? Common tangent. And what this is? This is a ground. There's a very basic one. I'm preparing. I'm taking help of this one. This is what is going to help you solve many problems. Common normal. So there's a block of, there's a sphere of mass m. It will approach the ground. I think this is very simple. No? You take any cricket ball or something, you just throw on the ground. It will rebound. No, the ground will be rough, will be smooth, depending upon all the conditions. So first, let me take the smooth here. Let's write all possible equations. What is the? Shall I say there's a line of impact? Then with what speed it will approach? It will approach with a speed u cos theta. It will rebound with a speed v cos alpha. Then the normal contact will act for small duration of time. The normal contact will act for small duration of time. So during that small duration of time, an impulse will act. I'll call JY. That normal contact force will act for small duration. What is JY? N into delta T. Now let's write impulse momentum equation first. Along x-axis, along y-axis, mu cos theta minus jy equal to minus mv cos alpha. What is in fact jy? Jy is equal to n into delta t. The normal contact acting between the ball and the ground for small duration of time will be jy. And we know that this ny will be very much greater than mg. Fine. So there's a one equation, you keep it. So this will be mu cos theta plus mv cos alpha equal to jy. This is impulse by the ground. Let's come for this quotient of restitution formula. Rebound speed by incident speed. So let me substitute v cos alpha above. So this will be mu cos theta u cos theta equal to jy. So what is jy is equal to u cos theta 1 plus e. So this impulse acting what depends the magnitude will it also depends upon the type of surfaces. The answer is yes. This is something very important. Books, okay, they're given equation, but definitely a student has to analyze. So the impulse acting between two surfaces depends on what? Depends upon E. What is E? E depends upon the nature of surfaces, no? And this M also will come. The quotient of restitution already we have just concluded, no? Previous classes, independent of masses, independent of size, but depends upon the nature of surfaces. So the impulse acting between the surfaces, well, it depends on nature of surface. The answer is yes. It depends on momentum and also in what direction the velocity directed, and also depends nature of surface. So I am able to define impulse like this by looking at the situations. Linear impulse depends also on nature of colliding. There's a very, you can say, dangerous statement not available in book. Why not available? Because I should not define in the impulse momentum equation. Only in the situation I should define. So as a teacher, I think I should not define it in the definition. You'll never understand because unless the situation doesn't come. So can be asked such things for you in advance. Hidden things, all these are. You have to be careful. Linear impulse depends also on nature of colliding surfaces. Then This is about the quotient of restitution, what we have, and this is the expression for JY. Along x-axis, were there any impulse will act? The ground is smooth. So along x-axis, momentum is considered. Net impulse along x-axis 0. So initial momentum mu sine theta should be equal to mv sine alpha. So therefore, u sine theta equal to v sine alpha. Is it okay? So this is a generalized idea of this one. So momentum is conserved along x-axis, along y-axis it is not conserved. After this, we'll take the types of collision. So we know elastic, inelastic, perfect inelastic. The first collision, let it be perfect elastic collision. Then what will happen to all these equations? E equal to 1. If E equal to 1, no loss in kinetic energy, no? Kf should be equal to Ki. Then mv square should be equal to mu square by 2. V equal to u. E equal to 1 in this equation. E equal to 1, V equal to u. So what do you expect? Alpha and theta must be equal. So alpha equal to theta. So the angle of incidence should be equal to angle of rebound. What are alpha, theta? How we define? Theta is called as angle of incidence. And what about alpha? We define alpha as angle of rebound. Second case, if E between 0 and 1, already we know it. If just I'll put it, E between 0 and 1, then Kf will be less than Kf not equal to Ki, better you write it. Then V not equal to U, then alpha not equal to theta. Or it can happen, V by cos theta. So this exclusively, let's not write anything that one. So this is what happens. Next again, if E equal to 0, if E equal to 0.
Sir, why did you not write it, sir?
What happened?
Sir, why did you not write alpha is not equals to theta?
It depends on the ratio of V by U and theta, no?
Okay, sir.
Mathematically, because I can write any equation, but not true in all cases, no? E equal to 0. So what will happen? If E equal to 0, shall we put V0? If E equal to 0, then what will happen? It can happen that cos alpha will be 90, no? V will be non-zero. It's not that V must be 0. So if E equal to 0, so what conditions will arise? V will be non-zero, alpha will be 90 degrees. Then after impact, so what actually happens to the ball? After collision, it will move with a speed u sine theta. The component of velocity along y-axis will become 0. So this you write Vx. So what is Vx equal to? U sine theta. It will not get stuck to it. It will move on the surface equal to 0. Then what is the impulse? You can write it. Jy is equal to mu cos theta only, because mu cos theta E equal to 0. So it will be only mu cos theta. Can we calculate loss in kinetic energy? Yes, we can determine. So E equal to, in one-dimensional collision, E equal to 0, the particles will get stuck. In two-dimensional collision, the particle need not to get stuck. So what is the, also like the bodies need not to stuck. What are bodies here? There's a ball and there's a ground. So will the ball will get stuck to the ground? No, only Y component will get eliminated. I think you have to be very careful about this condition. Okay, agree this? So this is about the two-dimensional collision. So like when a ball is incident at an angle theta with vertical and collides elastically, inelastic or perfect inelastic, all these are the sequence that will take place. So it's all about the writing impulse momentum equation. Are you getting this first set of equation? No, they are very important. So how you should proceed with the problem when it comes in contact, the normal contact you show it. So that most of the problems what we discuss will be normal contact, collision of two objects. When the two objects come in contact, normal contact will come. So what you should do, identify common tangent, then common normal, along common normal, impulse will act, then proceed the problem. Okay, let's take if the surface is rough. No, let it approach with an angle theta, it will rebound. Let this be rough.